Hello students, this is Mr. Ueda. Welcome to another math tutorial. Could you please open Geometer Sketchpad? Please type in this title and then type in your name box, first name, last name, class. First thing we want to do is we want to go to the Edit menu and go down to Preferences. I want you to change the angle precision to units, and I want you to change your distance precision to tenths. Then click OK. So what I'd like you to do is draw a fairly small triangle. We can move this triangle around, we can adjust it later. I want you to go ahead and measure the sides. And what we might do is right off the bat, we're going to adjust the the text, the font size of those measurements. And then I'll measure this side. And I'll measure the last side. It doesn't matter what type of triangle it is. Looks like I've drawn a scalene. That's probably the quickest one to draw. Alright, I want to create an interior for this triangle. So let's click on all 3 points in clockwise order, and let's go to Construct, Triangle Interior. It doesn't matter what color you choose. I'm just going to choose a light blue for my original triangle. Alright, let's measure the angles. So remember, go in clockwise order, endpoint, vertex, endpoint. Remember that the angle that you're measuring is the middle letter of your angle label. And make sure to measure all 3 angles. Place them on the corners of your triangle. Okay, so we're going to do something totally different. We're going to use the point tool, and I'd like you to construct a point somewhere outside of your triangle, but not too far away. So I'm just going to create it right here. And then I'm going to switch tools to the pointer or the selection arrow, and I'm going to double click on it, and you'll see that it will flash with rings for about a second. Okay. So I want to highlight my triangle, but don't highlight the point. I want to go to Transform, and I want to go to Dilate. Dilate by fixed ratio, and in the numerator I want you to type in 2, and the denominator I want you to type in 1. So this is a fraction of 2 over 1. In other words, a scale factor. We call it a scale factor of 2 to 1, or a scale factor of 2. Alright, let's click Dilate. So what you'll see now is you'll see a copy of your original triangle, but now it has been enlarged by a factor or a scale factor of 2. Okay? So what I want you to do is I want you to measure the angles first. So what we're going to do is we're going to go in the same order that I measured the angles on my original triangle. So I'm going to go to this endpoint, this vertex, and this endpoint, and go measure angle. And some interesting things happen. For one, you'll notice that the point labels. My original point was point A, and now my new point is called A primed, or A kind of just a little tick there. Okay? But I also want you to notice the angle measurement here. Notice the relationship between my original angle CAB and my angle C prime, A prime, B prime. Notice their relationship. They should be exactly the same. Alright, let's go to the next measure. Let's go to the next angle measurement. So I'm going to go A prime, B prime, C prime. I'm going to go to measure angle. I'm going to bring that measurement down here, and I want you to notice the relationship between angle ABC, 46 degrees in my diagram, and angle A prime, B prime, C prime is 46 degrees. In other words, these two angles are congruent. Alright, let's measure the last angle, angle B prime, C prime, and A prime. let's measure angle, and I want you to notice the relationship between angle BCA, which in my case was 74 degrees, and angle B prime C prime A prime, which is also 74 degrees. These two angles are congruent. So even though we enlarge the triangle, hopefully you've come to the conclusion that we have not changed the measurements of the angles. The angles stay exactly the same. Now, is that going to be true for the sides? Let's see. I hope you already have an answer in your head. All right, let's click on the first side, side CA, or in this case, side C prime A prime. Measure length. Okay, so let's look at these two measurements. The first measurement here, Geometer Sketchpad called side J, was 3.4 centimeters, and then in my enlarged diagram, I get J prime equals 6.7. So I want you to think of a relationship between these two numbers. All right, let's measure the next side. Measure length. So my original triangle had a length of 4.5 centimeters, and my new triangle has a measurement of 8.9 centimeters. And then let's measure the last side of our dilated triangle. Let's measure length. And then I want you to see the relationship between this length, 4 centimeters, and this length, 8 centimeters. Now this relationship is very easy to see, right? Hopefully you can see that this length is multiplied by 2 to get this length. Now in this case, 3.4 multiplied by 2 is not exactly 6.7. So there's got to be a reason why it didn't come out perfectly, and it's all because of our preferences. Because we changed the angle distance to tenths, it's always going to round to the nearest tenth. So this might actually be 6.78 or something. It just rounded it. Okay? And then the same happened here. 4.5 multiplied by 2 should be 8.9. But this measurement must have been rounded up. All right, let's put two labels here. All right, so for this one, let's call original triangle or original figure, since we're using the word figure in our title. Let's take off the underlining. Let's put that right here. And then I'll create another text box, and I'll call it the similar figure. So the whole point about this assignment is to get to the meaning of the word similar. It's not quite congruent, is it? There is some level of congruence, but it's not completely congruent. All right, so here we go with a pretty long conclusion. So you're just going to have to be patient. You're going to have to use that pause button a lot. Okay, so here we go. I created a fairly large text box, okay? And I don't need a very big font. I'll reduce it here. All right. Corresponding angle pairs. Okay. So let's review our angles. So let's get the angle symbol. So angle A prime, prime is just the apostrophe, right? B prime, C prime, and angle ABC, both equal. Now in my diagram, it's 46 degrees. Okay, in your diagram, it's going to be totally different. So what angles did I just talk about? This angle, angle ABC, and this angle, angle A prime, B prime, C prime. Okay, they are called corresponding angle pairs. They are the same angle in each triangle, and they have the same measurement. Okay? All right, I'm going to hit enter. So let's fill this out for the other corresponding angle pairs. So corresponding angle pairs. So let's go to the next pair. How about we go up here? Or how about we go over here? Angle BCA. So angle B prime, C prime, A prime. Oops. A prime and angle BCA equal, and in my case they both equal 74 degrees. 74 degrees. Period. And let's type in the statement for the last pair. So maybe I should put a space here. All right. Corresponding angle pairs. Angle, which ones haven't I done? I haven't done this one. Angle C, C prime, A prime, B prime, and angle CAB equals, in my case, my diagram, 59 degrees. Okay, so those are my corresponding angle pairs. Now let's talk about the corresponding side pairs. So, corresponding side pairs. So how about we use these letters? It might be easier for us. So K prime equals, in my case it's 8.9 centimeters, and side K equals 4.5 centimeters. So these are corresponding sides. They kind of are the same side in that position of the triangle. Okay? And the whole point is that they're not congruent. They are not equal. Okay? Let's go to the next corresponding side pair. Corresponding side pairs. So in this case, how about we use the L's? L prime equals 8.0 centimeters, and L equals 4.0 centimeters in my case. And then the last corresponding pair, corresponding side pairs, I'll use my last pair, J prime and J. J prime equals 6.7 centimeters, and J equals 3.4 centimeters. Okay? And I'm going to write a final statement here. The corresponding side pairs have a scale, sorry, bad typing, have a scale factor of 2. Now remember when we dilated it, the fraction was 2 over 1. This is why the scale factor is 2. Does that make sense? Okay. Now if you find that's too small and you've got a little bit more room, I actually had a little bit more room than I thought. Maybe I can bump that up to size 16. And that will still look very neat. Okay. Alright, I'm going to start another figure, and then you're going to take it the rest of the way. Okay? Alright, this time I want you to draw a medium size quadrilateral. Okay, it could be any quadrilateral as long as it's a closed shape. Alright, so let's go through measuring the angles. Remember, every angle has only 3 points, so don't click on the 4 points. Right, so here we go. Angle EFG, angle FG, whatever this is going to be. Angle GHE. Okay. Alright, I got my 4 angles measured. And then go ahead and measure your sides. Make sure you place each measurement in the right spot, whether it's on a side or whether it's on an angle. Okay. So this time I'm going to try to create, actually, sorry, let me construct the interior. Go to construct, and we're going to look for quadrilateral interior. And then I just want to change the color so it's different from my triangles. Okay? So this time let's try to create the dilatation point in the center. And let's see if that makes any difference. So I've created a point tool, and I'm going to create it inside. I'm going to switch tools to the selection arrow, and I'm going to double click, and then you'll see it flash for a second. Okay, so let's highlight the shape. Try not to get any other thing inside. and let's go to Transform, Dilate. And in this case, instead of 2 over 1, I want to reverse it to 1 over 2. And then click Dilate. All right. So it looks like for me, it created the new shape inside. So I think I can move that if I move that point outside. Okay, I really don't want one shape inside the other, because then our angle measurements and everything is going to be so difficult to read. All right, so I want you to go through and measure the 4 angles of your new shape, measure the 4 sides, and I want you to think about the relationships between corresponding angles and corresponding sides. I want you also to type in a conclusion here at the bottom. When you're done, please call me over. I want to have a look at this before you go on to the assignment. Now, once you've shown me the assignment, you're going to go to File, Open. You're going to go down to 4 students, double-click out, go down to UADA, go down to click on 705 Math, and then I want you to click on Drawing Similar Figures. And this is the assignment that I would like you to create. Here are my instructions. Okay? It's going to be very similar to this tutorial. All right, good luck. And so I'll be looking for 2 things in this to look at. Thanks for watching. Good luck. Bye.